Imagine you walk into a room and see a monkey sitting in front of a keyboard, aggressively mashing keys like it's trying to win a typing contest it doesn't understand. You take a look at the screen expecting to see complete gibberish, just a mess of letters with no big meaning. But instead, you see something strange. To be or not to be, that is the question. At first, you assume it's a prank. Maybe someone rigged the keyboard. Maybe it's a glitch. But what if it's not? What if, just by sheer luck, that monkey actually managed to type one of the most famous lines in human history, completely at random? Now take the idea and stretch it to its absolute limit. What if you gave that monkey infinite time? Not just a few hours or days, but literally forever. According to one of the weirdest thought experiments in history, if you let a monkey, or an infinite number of monkeys, smash keys for an infinite amount of time, it wouldn't just type one Shakespearean line, it would eventually type everything Shakespeare ever wrote. In fact, it would type every possible book, poem, song, or script that could ever exist. That means somewhere in that randomness, there's a perfect word-for-word copy of Hamlet. But also a version of Hamlet where every character is a talking pineapple, and a version where the play is just the word banana repeated for 200 pages. This is the Infinite Monkey Theorem, an idea that sounds ridiculous at first, but actually touches on some deep questions. Can randomness really create meaning? How likely is it for something ordered to emerge from pure chaos? And if this is true, what does it say about the universe itself? At this point, you might be thinking, okay, but is this actually possible? Or is it just one of those technically correct but completely impractical ideas? That's where things get interesting. Because mathematically, the answer is yes, it could happen. But practically, the odds are so astronomically low that the entire universe could die of heat death before you get so much as a single Shakespearean sonnet. But before we get into the numbers, let's break down exactly what this theorem is saying and why it matters. It sounds completely absurd at first. A monkey writing Hamlet? Come on! But mathematically it actually makes sense. The key word here is infinite, because once you allow an experiment to go on forever, every possible combination of letters must eventually appear. But let's be real, that doesn't mean the monkey wants to write Shakespeare. It's not sitting there pondering existential themes, wondering whether to be or not to be is the question. It's just a monkey hitting keys at random, producing complete chaos. To understand why this theorem is technically true, let's think about how randomness works. If you flip a coin an infinite number of times, at some point you'll get 100 heads in a row. It's rare, but given infinite chances, it's guaranteed to happen. The same logic applies here. A monkey typing at random is overwhelmingly likely to produce gibberish. But in an infinite timeline, it will eventually stumble upon meaningful words, sentences, and entire books just by pure chance. Now here's where things get even weirder. The theorem doesn't just say the monkey will type Hamlet once, it says the monkey will type every possible version of Hamlet. That means a perfect copy of Hamlet identical to the one Shakespeare wrote, a version where every word is misspelled, a version where every character is replaced by vegetables, a version where it starts as Hamlet but halfway through turns into a 900-page rant about bananas, a version that is written in perfect English but makes absolutely no sense, a version where it's just the letter A repeated forever. It doesn't stop at Hamlet either. The theorem predicts that somewhere in this infinite mess, the monkeys will type every book that has ever been written, every book that hasn't been written yet, every possible combination of words and letters that could ever exist. That means that right now, in some hypothetical infinity where this experiment is running, there's a perfect transcript of your life story, even the parts that haven't happened yet. There's a book titled with your exact name predicting every word you'll ever say, and another book that describes an alternate timeline where you become an astronaut instead. This is where the theorem goes from being a quirky probability experiment to something that makes you question reality. If infinite randomness can produce meaning, what does that say about the universe? Could everything we see around us, science, history, consciousness, be just one correct version of events that emerged from randomness? Now, before you start questioning existence itself, let's bring things back to reality. Because as mind-blowing as this idea is, there's a very, very big catch. Just because something is possible doesn't mean it's practical. In theory, a monkey could type Shakespeare, but how likely is it? What are the actual chances of this happening in a real-world scenario? That's where things get interesting, because the numbers behind this are so unbelievably huge that we may as well be talking about something that will never happen, not just in our lifetime, but in the entire lifespan of the universe. Let's get into the maths. How long would it actually take for a monkey to type even a single correct Shakespearean sentence? Let's find out. Probability. How likely is it, really? Alright, let's get into the numbers, because while the Infinite Monkey Theorem might sound cool, in theory, once you actually calculate the odds of it happening, things get, well, absurd. Let's start simple. Imagine a monkey sitting in front of a standard QWERTY keyboard. Every time it smashes a key, it has about 1 in 50 chances of hitting the right one, counting letters, spaces, and punctuation. That doesn't seem too bad, right? Now let's say we want the monkey to type the first word of Hamlet, 2. The letter T has a 1 in 50 chance of being typed correctly. The letter O also has a 1 in 50 chance. So, the probability of typing 2 correctly is 1 in 50 times 50 equals 1 in 2,500. Not great, but still somewhat imaginable. Now, let's add the next word, B. The letter B has a 1 in 50 chance. The letter E has a 1 in 50 chance. So, to type the phrase to be, our monkey's odds are 1 in 50 by 50 by 50 by 50 equals 1 in 6,250,000, or 1 in 6.25 million. Now let's try the full to be or not to be phrase. 18 characters, including spaces and punctuation. Probability, 1 in 50 to the power of 18. That number is worse than winning the lottery multiple times in a row, but we're just getting started. Now let's move to the full first line of Hamlet. To be or not to be, that is the question. That's 39 characters long. The probability of a monkey randomly typing that exact sentence is 1 in 50 to the power of 39. How big is that number? Well, 50 to the power of 39 is roughly 1 in 10 to the power of 66. That's 1 followed by 66 zeros. For perspective, the estimated number of atoms in the entire observable universe is about 10 to the power of 80. That means if every single atom in the universe had its own monkey typing 24/7 since the beginning of time, we still wouldn't have seen a correct Hamlet quote by now. But let's go even bigger. What about the entire text of Hamlet? That's about 130,000 characters. The probability of a monkey getting that right is 1 in 50 to the power of 130,000. That's a number so large that writing it out in full would take up more space than the known universe. At this point, you'd have better odds of shuffling a deck of cards and having it land in perfect order every single time you try. But let's not stop there. What about all of Shakespeare's works? That's around 900,000 words. At that scale, the probability of getting it right is so small that it's basically zero in any practical sense. The universe will die of heat death long before it happens. To really grasp how insane these numbers are, let's compare them to things we already know. You have a better chance of being hit by lightning every day for a century than a monkey typing just one correct Hamlet sentence. You have better odds of winning the lottery 100 times in a row than getting a single Shakespearean paragraph. The sun will burn out, the earth will be swallowed, and a new solar system will form before a monkey types even one correct Hamlet page. So while the theorem is technically true, in reality it's functionally impossible. Even with infinite monkeys typing for billions of years, you just end up with an overwhelming sea of random gibberish. And maybe, just maybe, a lucky phrase appearing once every few trillion years. And that raises an interesting point. Randomness alone doesn't create meaning. It's not enough to just generate infinite text. Someone has to be there to recognize when something meaningful appears. That's where things start to get philosophical. So, if randomness can technically produce structure but almost never does, what does that say about reality? Is the universe just a random mess, or is it something shaping the patterns we see? The big picture. Does randomness create meaning? At this point, the numbers are so ridiculously large that the Infinite Monkey Theorem starts to feel like a cosmic joke. Sure, given infinite time, a monkey could type out every work of Shakespeare. But in any real-world scenario, the odds are so impossibly low that it may as well never happen. And yet, this idea taps into something much bigger than just monkeys and typewriters. It forces us to ask a fundamental question. Can randomness actually create meaning? Or is meaning something that has to be shaped, guided, or recognized? Because here's the thing, randomness by itself is just chaos. If you took a massive randomly generated jumble of letters and numbers, somewhere inside that mess you'd find the complete works of Shakespeare, the blueprint for a time machine, and a perfectly accurate prediction of every event that will ever happen. But those meaningful sequences would be so rare, so drowned out by the noise, that no one would ever notice them. One of the most famous comparisons to the Infinite Monkey Theorem is biological evolution. Life, as we know it, emerged from random mutations over billions of years. Given enough time, tiny changes in DNA, guided by natural selection, led to the staggering complexity we see today. Some argue that this is an example of how randomness can produce order and meaning. Life is just a monkey typing random letters, except instead of a typewriter, it's DNA, and instead of infinite time, it had a few billion years to work with. But here's the key difference. Evolution isn't purely random. Yes, mutations happen randomly, but natural selection isn't random at all. It constantly filters out bad mutations and keeps the useful ones. It's not like the monkey is just typing random junk and accidentally getting Shakespeare. It's more like the monkey gets to keep the correct letters while erasing the wrong ones. This is why pure randomness, like a monkey with a keyboard, doesn't really create meaning. Without some kind of selection process, it's just an ocean of nonsense with tiny islands of coherence that no one will ever see. Let's go even bigger. The Infinite Monkey Theorem isn't just about probability. It actually ties into some of the biggest questions in science and philosophy. For example, some interpretations of the multiverse theory suggest that if there are infinite universes, then literally every possible universe must exist somewhere. That means that in some universe out there, Shakespeare was actually a monkey who typed out his plays by accident. And in another universe, you're the one who wrote Hamlet. That might sound insane, but the logic behind it is eerily similar to the logic behind the Infinite Monkey Theorem. If you have infinite chances, every possible outcome has to exist somewhere. But that also raises a strange thought. Is our own universe just one of those lucky, meaningful arrangements hidden in a sea of randomness? Is there a structure to existence, or are we just a rare, temporary blip in an otherwise meaningless cosmic soup? Let's bring this back to something more practical. Even if a monkey did type out all of Shakespeare's works, who would notice? If no one ever finds that page, does it even matter? This is where the Infinite Monkey Theorem stops just being a probability exercise and turns into something more philosophical. Meaning isn't just about something existing, it's about someone being there to recognize it. Think about it this way. If you had an infinite number of monkeys producing text, you wouldn't just get Shakespeare. You'd get every possible book in existence. That includes books that look like gibberish but actually contain deep truths, books that describe future events perfectly, books that contain the answers to every scientific mystery. But if no one ever sees those books, if they're lost in an infinite pile of nonsense, do they actually mean anything? It's kind of like how we think about science and discovery. The information is out there, hidden in the universe, waiting to be understood. But until someone puts in the effort to find it, interpret it, and make sense of it, it's just noise. So, in a way, the Infinite Monkey Theorem isn't just about probability, it's about the nature of knowledge itself. It suggests that randomness can generate meaning, but only if there's something in place to recognize, filter, and make sense of it. Which, when you think about it, is exactly how intelligence works. So, can randomness really create meaning? The answer is, kind of. Yes, randomness can produce structured, meaningful things, but not in any way that's useful on its own. Without something or someone to recognize and extract meaning from all the chaos, all you're left with is an infinite mess. That's the real takeaway from the Infinite Monkey Theorem. It's not just about whether a monkey could write Shakespeare, it's about whether, in a universe filled with infinite randomness, meaning actually matters if no one is there to see it. And that's a question that goes way beyond math. It touches everything from philosophy to artificial intelligence to how we think about the universe itself. But before we go too deep down the existential rabbit hole, let's get back to reality. Chaos, order, and the nature of the universe. At this point, the Infinite Monkey Theorem has taken us from probability to philosophy, forcing us to think about whether randomness alone can create meaning. But this idea also connects to something much bigger, the fundamental nature of chaos and order in the universe. Because if pure randomness can create Shakespeare, or life, or even the entire observable universe, then we have to ask, is the universe tending toward randomness or toward order? Let's break that down. At first glance, the universe seems like a place of increasing randomness. This is something physicists call entropy, the idea that, over time, everything moves toward more disorder. A hot cup of coffee eventually cools down. A sandcastle eventually crumbles into a random pile of sand. A star eventually burns out into scattered dust and radiation. We talked about this in one of my previous videos. I'll link it in the description. In other words, if you leave things alone for long enough, order eventually breaks down. But here's the weird part. Despite this universal tendency toward chaos, order still emerges everywhere. Stars form, planets stabilize, life evolves, intelligence appears. Somehow, in this vast chaotic universe, patterns keep showing up. And that's exactly what makes the Infinite Monkey Theorem so fascinating. It suggests that if you have enough randomness and enough time, patterns, structured, meaningful things must eventually appear. So is that what's happening in the universe? Are we just one of those rare ordered patterns in an otherwise random mess? If the universe is supposed to be falling apart over time, why does it keep producing things that are not random, like galaxies, planets, and complex life? One answer is self-organization. Some systems have natural rules that lead to order emerging from chaos. We see this everywhere. Snowflakes form intricate symmetrical patterns from completely random water molecules. Galaxies emerge from swirling clouds of chaotic dust and gas. DNA arranges itself into a stable code that produces life. This isn't just some weird coincidence, it's something built into the physics of how our universe works. Even in a system driven by randomness, some rules naturally create structure. And that's where the Infinite Monkey Theorem starts to look a lot less like an absurd joke and a lot more like a fundamental truth about reality. Taking this a step further, if pure randomness can eventually produce order, then what if our entire universe is just one of those lucky outcomes? In the multiverse hypothesis, which suggests that our universe might not be the only one, instead there could be infinite universes, each with different laws of physics. Some of them are complete chaos, nothing but random particles drifting forever, but others, just by pure chance, might have stable laws of nature that allow for galaxies, stars, planets, and even life. In other words, if you imagine the entire multiverse as an infinite number of monkeys smashing random keys, our universe just happens to be the one that accidentally typed out something that works. That's a pretty wild idea. It means that instead of our universe being uniquely special, it could just be a lucky statistical accident, one tiny pocket of structure in an infinite sea of chaos. And if this theory is correct, then there are other universes where the physical laws are slightly different, where maybe gravity works backwards, or where time flows in reverse, or where intelligent life evolved in ways we can't even imagine. But there's a catch to this. Just like in the Infinite Monkey Theorem, most of these random universes would be completely meaningless. They'd be gibberish. The vast majority would be nothing but empty, chaotic randomness. The ones that actually make sense would be incredibly rare. Which again sounds a lot like what we saw with the monkeys and Shakespeare. So, is the universe random or designed? This is where things get really interesting. If randomness can create meaning, then it raises a huge question. Is our universe just one of those lucky random patterns, or is there something deeper guiding it? Some scientists believe that the laws of physics themselves might act as a kind of selection process, just like natural selection in evolution. Maybe certain laws are more stable, meaning that only certain kinds of universes survive long enough to produce life. Others argue that there has to be something more, that pure randomness alone isn't enough to explain why our universe seems so well structured. This is where the debate between random chance and intelligent decision comes in. Because if you believe that randomness can eventually create meaning, then everything we see, from Shakespeare to galaxies to our own thoughts, could just be the result of one lucky accident in an endless sea of gibberish. But if you don't buy that, then you're left with another possibility. Maybe the universe isn't random at all. Maybe it was built to create meaning. And that's what makes the Infinite Monkey Theorem so much bigger than just a silly thought experiment. It starts as a joke about monkeys and typewriters, but ends up touching on some of the deepest questions in science and philosophy. Can pure randomness create something meaningful? If the universe is just randomness playing out over time, why do we see so much order? Is our universe just one lucky accident, or is there something guiding it? These are questions we still don't have answers to, but one thing is clear: whether we are monkeys at typewriters or just lucky observers in a chaotic universe, meaning only exists if we're here to recognize it. But enough theory. Let's move from cosmic ideas to actual monkeys, because believe it or not, someone actually tried this experiment in real life with real monkeys. And the results? Well, let's just say they were a lot less philosophical and a lot more bananas. The time we actually gave monkeys a keyboard. Back in 2003, a group of researchers from the University of Plymouth in the UK decided to put this idea to the test with real monkeys. They placed a computer in an enclosure with 6 Sulawesi-crested macaques, a species of small monkeys, gave them a keyboard and waited to see what would happen. The hope? Maybe they'd get a few words, or at least something resembling structured text. The reality? The monkeys spent most of the time banging on the keyboard randomly, produced nothing even remotely close to words, managed to type exactly 5 pages of pure gibberish, smashed the keyboard with a rock, and best of all, pooped on it. That's right, before they could even produce Hamlet, the monkeys lost interest and literally crapped on the experiment. The final report from the researchers? The random keystrokes hypothesis lacks empirical support. So, in short, the experiment was a complete disaster, but it also revealed something important. Real monkeys do not behave like theoretical monkeys. A mathematical monkey exists in an abstract world where it types endlessly, never getting bored, never smashing the keyboard with a rock, and never walking away to do something more interesting. Real monkeys? They're unpredictable, messy, and frankly don't care about your thought experiments. This is one of the biggest flaws with the Infinite Monkey Theorem. It assumes that, given infinite time, a monkey will keep typing forever. But in reality, the monkey would probably just leave before it ever got anywhere close to a meaningful sentence. Since real monkeys didn't quite live up to expectations, researchers have also tried testing the Infinite Monkey Theorem using computers. After all, a computer can simulate a monkey that never gets bored, never takes a break, and never smashes the keyboard with a rock. One of the most famous attempts happened in 2011 when a group of programmers created a virtual monkey typing simulation. They set up a program that randomly generated characters at high speed, essentially mimicking the actions of a theoretical monkey at a keyboard. The results? After trillions of keystrokes, the program successfully produced one of Shakespeare's works. Sort of. It managed to type a 24-character sequence from Henry IV Part 2, and this tiny fragment took massive computational power and trillions of random attempts. So, could a computer eventually generate the full works of Shakespeare? Yes, but it would take an unimaginable amount of time. Even a computer generating random text at extreme speeds would take longer than the lifespan of the universe to produce anything remotely close to Hamlet. In other words, even when we remove the real-world limitations of monkeys, the theorem still remains completely impractical. As ridiculous as these monkey experiments were, they actually highlight something deeper. Randomness alone isn't enough. Infinite time isn't realistic. And patterns don't emerge on their own. This is exactly why evolution doesn't work like the Infinite Monkey Theorem. Natural selection, as we talked about before, isn't random. It constantly filters out bad mutations and keeps the useful ones. If life had evolved purely by random trial and error, without any kind of selection, we wouldn't be here at all. So, if real monkeys can't type Shakespeare and even simulated monkeys struggle to produce a single coherent sentence, what does this mean for the theorem? It means that while the Infinite Monkey Theorem is technically true in a mathematical sense, it is completely meaningless in reality. Even with infinite time, the sheer scale of randomness makes it practically impossible for anything meaningful to appear in a useful time frame. And yet, we still see patterns, structure, and meaning all around us. Which brings us to the next big question. What does this all mean for AI and the future of creativity? What this means for AI and the future of creativity. By now, we've established that randomness alone doesn't create meaning, at least not in any way that's useful. The real world isn't infinite, and neither are our lifespans. So waiting around for a monkey, or even a supercomputer, to type Shakespeare just isn't practical. But here's where things get interesting. What if we didn't have to rely on randomness alone? What if we could guide it? And that's exactly where artificial intelligence comes into the picture. Is AI just a smarter, infinite monkey? At first glance, AI might seem similar to the Infinite Monkey Theorem. After all, modern AI models like ChatGPT and other large language models don't think in the way humans do. They don't have creativity in the same way a human writer does. Instead, they rely on probability, predicting the next most likely word, phrase, or idea based on a vast data set of text. Sounds a little like randomness, right? But there's a key difference. AI isn't typing randomly. It's making structured predictions based on patterns it has learned. In other words, AI is like a monkey that has been trained to recognize patterns, correct mistakes, and refine its output over time. It's not just smashing keys forever and hoping something useful appears. It's learning from past text and making educated guesses about what comes next. This is a fundamental shift from the Infinite Monkey Theorem. Instead of relying on raw probability and infinite time, AI uses training data, algorithms, and optimization to generate meaningful text in seconds. It's more like having a monkey that gets instant feedback every time it types a wrong letter, quickly adapting until it learns how to write coherent sentences. Let's take this to the extreme. Suppose you trained an AI model without ever showing it Shakespeare's works. could it still generate something Shakespearean just by relying on probability and pattern recognition? Surprisingly, the answer is yes, at least in theory. Given a big enough dataset of English writing, the model would start to recognize how Shakespearean language is structured. It would pick up on the patterns of iambic pentameter, the poetic structure, and the frequent use of certain phrases. Over time, it might start generating text that resembles Shakespeare even if it has never seen his actual works. This is a lot like what the Infinite Monkey Theorem claims. Randomness, given enough chances, can produce something structured. But AI speeds up the process dramatically. Instead of waiting for a random monkey to type the right words by accident, AI learns the underlying structure and fills the gap with intelligent guesses. This is why AI-generated writing can sometimes feel eerily human. It's following patterns that already exist in human language, just like how an experienced writer instinctively knows what sounds right. Now, this raises a big philosophical question. If AI can generate meaningful text, is it actually creative, or is it just an advanced version of the Infinite Monkey Theorem? Right now, AI doesn't truly understand what it writes. It's not having original thoughts or experiencing creativity the way humans do. It's more like a machine running a highly optimized version of trial and error, adjusting probabilities and refining patterns until it produces something coherent. But here's the thing. Isn't that kind of what human creativity is too? Think about it. When you write, you're not inventing language from scratch. You're drawing on things you've read, things you've experienced, and ideas you've encountered before. Your brain is constantly testing, refining, and filtering thoughts, selecting the best ones based on past experience. In a way, human creativity is just an advanced version of pattern recognition, a highly optimized way of making meaning from randomness. So the real question isn't whether AI can be creative, but whether creativity itself is just a form of structured randomness. As AI continues to improve, we might reach a point where it can generate works that are indistinguishable from human writing, maybe even Shakespeare-level works. But will those works have true meaning, or will they just be highly sophisticated randomness? This ties directly back to the Infinite Monkey Theorem. If meaning only exists when someone recognizes it, then maybe it doesn't matter who or what creates the words. What matters is whether they resonate with an audience. And if that's true, then AI might not just be the next evolution of the Infinite Monkey Theorem, it might be proof that intelligence itself is just structured randomness. But before we get too deep into existential philosophy, let's wrap this up. Because after everything we've explored, from probability to evolution to EI, the Infinite Monkey Theorem still leaves us with one final, mind-bending question. If randomness can create meaning, and if infinite monkeys could eventually write Shakespeare, then what does that say about us? Are we just the lucky product of cosmic randomness? Are our thoughts, ideas, and even this video just the result of chaotic particles following patterns over billions of years? Or is there something deeper at work? Some kind of guiding principle that filters the randomness and shapes it into something meaningful? The Infinite Monkey Theorem is a reminder that probability can create anything, but meaning only exists if there's someone to recognize it. So in the end, maybe it doesn't matter whether a monkey could type Shakespeare. What matters is that someone is here to read it. And that, more than anything, is what separates us from the monkeys.